Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Shazrah binti Kamarul Zailan at 63199, and today I would like to present about solid state induction motor drives SSDs. First, we will see what is induction motor and what is SSDs or solid state induction motor drives. First is induction motor. Induction motor is a constant speed and a self-starting alternating current motor, known as constant speed motor. Solid-state induction motor drives are most used technique for the speed regulation of the induction motor is the solid-state variable frequency induction motor drive. The flexibility of this drive is very high, and the output of this solid-state drive is a three-phase. And now we will see the difference between traditional and the current SSDs. For the traditional, there are limited speed control options. They are less efficient due to wasted energy, and they are also can be less reliable with mechanical components. But for SSDs, the current one, they are more precise control over motor speed and torque, improve efficiency through optimized voltage or frequency, and also increase reliability with electronic components. Traditionally, induction motors were controlled with methods like pole changing, offering limited options. SSDs revolutionized this by providing precise control and improved efficiency. They achieved this through the use of power electronics, making them more reliable as well. An SSD is made up of several key components. The rectifier converts incoming AC power to DC. The DC link capacitor stores this DC energy and acts as a buffer. The inverter that converts the DC power bank into AC, but with variable voltage and frequency to control the motor. And finally, the control unit receives information from sensors like speed and current and uses this to precisely control the inverter for optimal motor operation. How does SSD work? First is the AC power in. The system starts by receiving regular AC power from the main supply, and then rectification. This AC power enters the rectifier, which acts like an electronic one-way valve. It converts the incoming AC voltage into DC voltage. DC link. The DC voltage is then stored in the DC link capacitor. This capacitor acts like a temporary reservoir, smoothing out any fluctuation in the DC voltage and providing a stable supply for the next stage. And then inverter or the powerhouse. The DC power from the capacitor gets fed into the inverter, the heart of the SSD. This clever component uses power electronics to rapidly switch the DC voltage on and off. By controlling these on-off cycles very precisely, the inverter converts the DC voltage back into AC voltage, but with two key differences. And then variable voltage. The inverter can adjust the peak voltage of the output AC waveform. There are variable frequency also, which is the inverter can control how often the AC waveform cycles on and off. And then next is the precise control. This ability to control both voltage and frequency is what gives SSD their power. By adjusting these parameters, the SSD can influence the magnetic field within the motor, which in turn affects the speed and torque of the motor. And lastly is the control unit or the brain. The control unit is the brain of SSD, and it receives signal from sensors such as motor speed and current sensor and compares them to the desired motor operation. Based on this comparison, the control unit sends instruction to the inverter, constantly adjusting the voltage and frequency of the output AC to achieve the precise speed and torque required for the application. And now we will see the benefits of SSD. First is to improve efficiency. They optimize voltage and frequency for the motor and save energy, especially for variable for speed applications. Better speed control. Precise control over motor speed enables efficient operation of machinery and processes. And lastly is increased reliability. Eliminates mechanical components prone to wear, contactors or relays, and reduces maintenance costs and improve overall drive system reliability. For conclusion, solid-state induction motor drive represent a leap forward in AC motor control. They provide precise control, improve efficiency, and increase reliability compared to the traditional methods. These advantages translate to real-world benefits like energy savings, better process control, and reduced maintenance costs. As industry's demand for efficiency and control continue to grow, solid-state induction motor drives are sure to be a key technology in the future of AC motor application.